Let's take a closer look at how a bottle jack works. First of all, a hydraulic jack is a device used to lift heavy loads. It consists of a body, a base with a large surface area to provide stability, a saddle which is used as the contact surface between the hydraulic jack and the load, a handle that is used to apply pressure to the hydraulic oil. Let's take a look at the inside of the bottle jack. This is the oil reservoir. This is the pump piston, which moves inside of the pump cylinder. When moving the handle up and down, the pump piston will move up and down inside the pump cylinder. This is the main cylinder in which the main piston can move through it. The main piston is connected to the saddle, which will lift the load by applying pressure to it. There must be a tight seal at any of the pistons. This is a check valve that is placed in the line connecting the oil reservoir by the pump cylinder. It only allows motion of fluid from the oil reservoir to the pump piston and preventing the backflow of it. There is also a check valve in the line connecting the pump cylinder and the main cylinder. This check valve only allows the flow of oil from the pump cylinder to the main cylinder and prevents the backflow. The working principle of a check valve is very simple. It is a ball that is spring-loaded to a conical hole called the seat. When the pressure is higher in the lower part, it will move the ball and compress the spring to allow the flow. While if the other way around, the ball will close on the seat and it will prevent the flow in the other direction. The main purpose of the hydraulic jack is to magnify the input force by a suitable amount to lift heavy loads. It relies on two methods to do this. The first one is the lever method. If you have a rod pivoted at a point and you apply a force at the end of the arm, the torque corresponding to this force is equal to the force multiplied by the distance. If you somehow outputted this torque into something that is closer to the pivot, the force outputted will create the same torque. But now, since the second distance is smaller, the outputted force must be larger. The factor of amplification will be the ratio between the arms of the two forces. This doesn't violate the law of conservation of energy, because the smaller force must travel a large distance while the larger force will travel only a small distance. This is very clear when you tighten nuts using wrenches. Large wrenches require less force due to its larger arm. This principle also holds true for the bottle jack. When you apply a force at the end of the handle, it gets amplified to the pump piston due to the lever action. The second amplification in the force happens due to Pascal's principle. Pascal's principle states that if you apply a pressure to a fluid, it will be transmitted to the whole fluid and increase the pressure of the whole fluid by the same amount. So if you have two cylinders, a large one and a small one, when you apply a force at the smaller one, it will create a pressure that will be transmitted to the whole fluid. The pressure equal to force divided by area. This pressure will be transmitted according to Pascal's law, outputting a force of magnitude pressure multiplied by the area on the other side. But since the area is larger, the force will be larger by the ratio of the areas. Again, this doesn't violate the law of conservation of energy, because the volume of the fluid transmitted between the cylinders is the same. But since the amount occupies a smaller radius in the small cylinder, the displacement must be larger compared to the larger cylinder. Let's jump to the bottle jack to see this principle in action. The force being transmitted to the pump piston will increase the pressure, which will result in a flow of oil. But as you can see, the check valve connecting the pump piston with the reservoir will close, because this is a restricted flow direction. So the only way for oil to flow is to the main cylinder. And since the main cylinder has a large area compared to the pump piston, the force will get amplified again. But because these amplifications of the force reduces the displacement a lot, we will need to do this motion a number of times without descending the load each time. When you stop moving the handle, the pressure in the main cylinder will try to create a flow to the pump cylinder, but the check valve will prevent this. When you move the handle up, the entrapped volume will increase, which will create a vacuum. This vacuum will be able to suck oil from the oil reservoir, and then this cycle will be created again and again to lift the load to the required height. At the end of the work, you will need to lower the load safely. This is where the relief valve came to play its role. It is placed in a passage that connects the main cylinder and the oil reservoir. It is threaded connected, which means as you rotate the relief valve, a flow will be allowed to move from the main cylinder to the oil reservoir. This controlled flow of oil will safely lower the load. And here you have it. If you like the video, don't forget to like and subscribe. Thanks for watching.